Hello everyone, I'm your Kuya Sevi for our little trivia. Today, we are going to discuss about plate boundaries, plate tectonics, three possible driving forces of tectonic plates, and continental drift theory. One scientist who looked at the pieces of this puzzle was Alfred Wegener. In early 90s, he wrote about the theory of continental drift. Continental drift is the theory that continents can drift apart from one another, and have done so in the past. This theory seems to explain a lot of puzzling observations, including the very good fit of some of the continents. Continental drift also explains why fossils of the same plants and animal species are found on both sides of the Atlantic Ocean. Let's move on to plate tectonics. Plate tectonics is the theory that the Earth's lithosphere is divided into tectonic plates that moves around the top of the asthenosphere. Let's proceed to plate boundaries. All tectonic plates have boundaries with another tectonic plates. These boundaries are divided into three main types, depending on how tectonic plates move relative to each other. Tectonic plates can collide, separate, or slide past each other. When two tectonic plates push into one another, the boundary where they meet is called convergent boundary. What happens at a convergent boundary depends on what kind of crust, continental or oceanic, the leading edge of each tectonic plate has. There are three types of convergent boundaries: continental to continental, continental to oceanic, and oceanic to oceanic. Next is divergent boundary. Two tectonic plates move away from one another. The boundary between them is called a divergent boundary. Do you remember seafloor spreading? The mid-ocean ridges that mark the spreading centers are the most common type of divergent boundary. Remember, divergent boundaries are where new oceanic lithosphere forms. The last type of plate boundaries is transform boundaries. When two tectonic plates slide past each other horizontally, the boundary between them is called a transform boundary. The San Andreas Fault in South California is a good example of a transform boundary. This fault marks the place where the Pacific Plate and the North American Plate slide past each other. At a transform boundary, two tectonic plates slides past one another. Because tectonic plates are not smooth, they grind and jerk as they slide. People who live in South California can feel these frequent jerks. They call them earthquakes. An incredible amount of energy is needed to move something as massive as a tectonic plate. We still don't know exactly why tectonic plates move as they do, but recently scientists have came up with some possible answer. There are three possible driving forces of plate tectonics. First is the ridge push. At the mid-ocean ridges, the oceanic lithosphere is higher than it is where it sinks beneath continental lithosphere. Ridge push is the process by which an oceanic plate slides down the slope of the lithosphere asthenosphere boundary. Next is slab pull. When an oceanic plate collides with a continental plate, the oceanic plate is forced down into the asthenosphere. Because it is denser than the material in the asthenosphere, the edge of the oceanic plates sinks and pulls the rest of the tectonic plates with it in a process called slab pull. Last but not the least, convection. In the process of convection, hot material from deep within the earth rises while the cooler material near the surface sinks. When the warmer material cools, it becomes denser and begins to sink back down. The motion of convicting mantle materials drags tectonic plates sideways. And that's